All right, I'm going to try to explain this paper to y'all. We're actually using these in a lab today where we use these little periodic table tiles. So y'all are going to have to do it just a little bit differently. So bear with me and hopefully you'll get what I'm kind of saying here. All right, so you have a list of these compounds here. Now we know these are compounds because there's a capital C and a capital O, and a capital H, capital O, capital N, capital O. So you can tell that there's multiple element symbols. So there's multiple elements, and two or more elements that are chemically combined would be a compound. So what you're going to do is look at each compound, and you're going to pull out or tell me what elements are present. So when we're talking about elements, we're only looking at the symbols. I'm not worried about the number when I'm asking about elements. Okay, so there's carbon and oxygen that's present. Now, when I get to this side, the model, now I'm looking at the number of atoms for each element. So this is where the number comes into play. So the C right here, there's no number directly beside the C. So it's an understood 1. So there's 1 carbon atom. And there's a 2, the subscript 2, beside the oxygen. So that means that there's 1, 2 oxygen atoms in this compound. So that's how you would build this compound. So if I was using Legos to represent this, this one could represent the carbon because there's 1 carbon atom and there's 2 oxygen atoms. So I could use those to represent the oxygen, and then they get put together, combined to make a compound. Now, the good thing about using Legos and such, or as the sheet will call it, a snap together toy, is that it gives you kind of a good visual of 2 elements being combined and how many of each element, how many atoms of each element can make that compound. The bad thing is that compounds cannot be physically separated, and these can. So a compound can only be chemically separated. Mixtures can be physically separated, but a compound can only be chemically separated. I can't ask you, hey, will you pull out the carbon there out of that carbon dioxide and separate it from the oxygen? No, that doesn't really work that way. So it's a good visual, but not 100% accurate, but it's just kind of one of those things to try to help you out. So if you think about it in your mind, there's 1 carbon, 2 oxygen. Then here, since y'all don't have the actual tiles to build it, you're just going to draw it. So you're going to draw your carbon and your 2 oxygens. And that's kind of how we'll do that. All right. So on these down here, I want to give you a word of advice. Be very careful because this is H and that is Cl, not Ci. Same thing here. This is Na and this is Cl, not Ci. Okay. So let's do one more together. H2O, that's water. So the elements that we see are hydrogen. Forgive me, it's really hard to hold the paper down and write. And that's with an H. And then the O is oxygen, and that's represented with an O. So right here, it's only the elements listed, not how many of each, just what elements. Now is when you look at the numbers. So for this one, we have 2 hydrogen and 1 oxygen. So that is what we're going to draw here. We have 2 hydrogen, awful drawings, that's okay, and 1 oxygen, okay? All right, so then you have 2 questions down here at the bottom. On the back of your paper will look like this. So in this section right here, you're just going to look at the substance and tell me, is it an element or a compound? And pay close attention to your element symbols where you have those capitals and those lower cases will give you a big clue. And you can just write an E or a C, whether it's an element or a compound, okay? All right, let's see. I want to give you a little heads up on some of these here. So number 3, it says, why is a compound a pure substance, although it's made from more than 1 element? Well, if you think back to the definition of an element itself is a pure substance. So if a compound is made of things that are pure, it still stays pure. All right, and then this question right here we talked about as a class. So it says, what can be said about the percentage of elements found in significant amounts in Earth's biosphere, living things, lithosphere, land, hydrosphere, water, and atmosphere, air, compared to the total number of elements listed on the periodic table? All right, so if you think about it, on the periodic table, there are 118 elements, okay? When you did the foldable on the biosphere, lithosphere, hydrosphere, atmosphere, we didn't write down 118 elements. In our foldable, we only listed about 8 elements, okay? Because in our foldable, we only listed the top most abundant elements that are found in these parts of Earth. So if you think about those two numbers, what does that mean? How can you compare that? So in all the spheres of Earth, only a small amount of elements are actually in abundance. The rest of them, there's really not that much of them within the Earth. They're present, but there's not that much. All right, and then these last two questions here, it calls the Legos the Snap Together toys. But so this one just asks you, what's an advantage of using the Snap Together toys? Is it helpful? Is it not? And then here's the disadvantage for using it. So think about those things. Let me know if you have any questions. And just send me a message if you have questions. Have a great day.